Class 12th chemistry, aldehydes, ketones and carboxylic acids, and we were discussing chemical reactions of aldehydes and ketones, and in this video we will discuss about oxidation of aldehydes and ketones. First of all, oxidation of aldehydes. Aldehydes differ from ketones in their oxidation reactions. Aldehydes are easily oxidized to carboxylic acids having same number of carbon atoms than the parent aldehyde. And the oxidizing agents used may be strong or may be mild. Strong oxidizing agents are nitric acid, potassium permanganate, potassium dichromate. Mild oxidizing agents are Tollens reagent and Fehling's reagent. And the mild oxidizing agents are used to distinguish aldehydes from ketones. See the reaction. This is aldehyde on oxidation convert into carboxylic acid. If we take the particular example like this ethanol, 2 carbon atoms are there. On oxidation this will convert into ethanoic acid. Again 2 carbon atoms are there. Okay. Oxidation of ketones. Ketones are generally oxidized under vigorous conditions. That is strong oxidizing agent and at elevated temperatures. Their oxidation involves carbon-carbon bond cleavage to give a mixture of carboxylic acids having lesser number of carbon atoms than the parent ketone. Now just compare with the aldehyde. Aldehydes are easily oxidized and on oxidation give the carboxylic acid having the same number of carbon atoms, while ketones are not easily oxidized and if oxidized in the vigorous condition give a mixture of carboxylic acid having lesser number of carbon atoms. Now just see one particular example, CH3, CH2, CO, CH2, C2H5. When this is oxidized, carbon-carbon bond cleavage is taking place. Now if bond is broken, that is cleavage of this bond is taking place. That is, if we number this is 1, 2 and 3, then by cleavage of this C1 and C2 bond, we will get this will convert into ethanoic acid CH3COOH, and this part will convert into C2H5CH2COOH, that is butanoic acid. Clear? The same way, if cleavage is taking place between this C2 and C, that is we can say that this one C2 and C3, from this, if cleavage is taking place from this one, then you can say this part will convert into carboxylic acid, that is CH3CH2COOH, propanoic acid, and this part will also convert into carboxylic acid, and this is C2H5COOH, it is propanoic acid. Okay, in this way we will get the different products. Now Tollens test. This is also known as the silver mirror test. This is done with the help of Tollens reagent and ammoniacal silver nitrate solution is called Tollens reagent. When aldehyde is heated with the Tollens reagent, you will get the silver metal. A bright silver mirror is produced due to the formation of silver metal. You can perform this test in a test tube. Then inside the wall of the test tube is deposited with the silver and this appears like a mirror. That's why this is silver mirror test. The aldehydes are oxidized to corresponding carboxylate anion, and the reaction occurs in alkaline media. See this aldehyde, this is oxidized to this carboxylate anion, and this silver which present in this, here oxidation number of silver is +1, and this will convert into metal silver where its oxidation number is 0. This is reduced. Okay. Fehling's test. Fehling reagent comprises of two solutions, Fehling solution A and Fehling solution B. Fehling solution A is the aqueous copper sulfate and Fehling solution B is the alkaline sodium potassium tartrate, that is Rosle salt. Okay. These two solutions are mixed in equal amounts before test. On heating an aldehyde with Fehling's reagent, a reddish brown precipitate is obtained. Aldehydes are oxidized to corresponding carboxylate anion. Aromatic aldehydes do not respond to this test. See this aldehyde, this is converting into carboxylate anion and this is Cu2 plus. Now again see the oxidation number of copper is plus 2 and when this will convert into cuprous oxide which is appear as a red brown precipitate, the oxidation number of copper is plus 1. That's why we can say copper is reduced and aldehyde is oxidized. Now this test is given by the aldehydes only, not ketones. And in aldehydes only aliphatic aldehydes. Aromatic aldehydes do not give this test. We will get this brown precipitate. In case of ketone, we will get the negative test result. Oxidation of methyl ketones by haloform reaction. Aldehydes and ketones having at least one methyl group linked to the carbonyl carbon atom, that is methyl ketones. Simply this type of aldehyde and ketones is represented like this CH3CO. This group must be present, and to this side any, if hydrogen may be there, any methyl, ethyl, any other alkyl group may be there. Okay, and this carbonyl atom, that is methyl ketones, are oxidized by sodium hypohalite to sodium salts of corresponding carboxylic acids having one carbon atom less than that of carbonyl compound. The methyl group is converted to haloform. See, this is a reaction. Now in this case, this is methyl ketone. Okay. Now this part, this will convert into haloform, that is CHX3, and this RCO, this will convert into this sodium salt of carboxylic acid, RCOONA. See one more example. Now this is the carbonyl group, and to this carbonyl group this methyl group is attached, and when this is treated with, this is sodium hypochlorite. Okay, sodium hypochlorite, NaOCl. Then this CH3 will convert into chloroform, CHCl3. And this part will convert into its sodium salt, that is COONA. Clear? Now iodoform test. Now in case of haloform reaction, if we specifically obtain iodoform, then that test is known as iodoform test. And again, it is given by the compounds having CH3CO group or CH3CHOH, and this is used for detection of compounds having CH3CO group or CH3COH group. And when these compounds are treated with the sodium hypoiodide, sodium hypoiodide is NaOI. And actually this NaOI is obtained by the reaction of I2 and NaOH. Then this will convert into iodoform, CHI3. And this iodoform is a yellow colored compound, that is yellow in color. Okay, and during this reaction, this CH3CHOH group produces CH3CO group on oxidation. Simply we can say actually this is CH3 and this is CHOH. Okay, first of all, this will convert into CH3C double bond. Okay, then this will react with the sodium hypoiodide and form yellow colored iodoform. Reaction can be represented like this is RCOCH3. This part will convert into CHI3 and this part will convert into RCOONA. Now this is the, you can say this is CH3CHOH. Okay, Now again, in this case, when this is treated with the I2 and NaOH, this part will convert into iodoform CHI3, and this remaining part will convert into sodium salt of carboxylic acid. This is iodoform test. Now see one example. It is 12.4. An organic compound A with molecular formula C8H8O forms an orange-red precipitate with 2,4-DNP reagent. Okay, that is, this compound gives DNP test and gives yellow precipitate on heating with iodine in presence of sodium hydroxide. It is also giving iodoform test. It neither reduces Tollens or Fehling reagent, nor does it decolorize bromine water or Bayer's reagent. Bayer's reagent is the alkaline KMnO4. On drastic oxidation with chromic acid, it gives a carboxylic acid B having molecular formula C7H6O2. Identify the compound A and B and explain the reactions involved. Now, how can we write the answer? First of all, whatever the hints given in this question, we will try to find out the properties of that compound. Like A forms 2,4-DNP derivative. It means A may be an aldehyde or it may be a ketone. It does not reduce Tollens or Fehling reagent. It means A must be ketone because aldehydes will respond to Tollens and Fehling reagents. Okay, that's why it is not aldehyde, it is a ketone. And A respond to iodoform test, it means A must be a methyl ketone. Clear? Now, the molecular formula of A indicates high degree of unsaturation. That is, formula of A, this is C8H8O. This representing the high degree of unsaturation, means presence of double bond. But yet it does not decolorize bromine water or Bayer's reagent. It means it is not alkene. Then in what way this unsaturation is present? It indicates the presence of unsaturation due to an aromatic ring. On that basis, we can see that is compound B is a carboxylic acid with the formula C7H6O2. This is the molecular formula and this contains the one aromatic ring. That's why B is benzoic acid C6H5COOH. And compound A, this is methyl phenyl ketone. This is acetophenone C6H5COCH3. Reactions can be written like this. This is A, methyl phenyl ketone. When react with the 2,4-dinitrophenyl hydrazine, we can say that is this O from this and H2 from this will eliminate out and we will get this 2,4-DNP derivative. And further, when this compound A reacts with this H2CrO4, that is on oxidation, this will give this benzoic acid. Okay, and when this is treated with the NaOH and I2, that is iodoform test, then this will form yellow colored CHI3. These are the reactions. Okay, thank you.